Hi everyone and welcome. In today's lesson we'll be looking at theorem 4, and what does it say? It says that when two angles are on the circumference of a circle and on the same side of the chord or arc that subtends them, then the two angles are equal. Now let me quickly show you what all of this means. Now here we have angle A on the circumference, here we have angle B on the circumference. Both of these angles are subtended by this chord or arc, which is called DC, and both of these angles are on the same side of that chord. In other words, this angle and this angle are both above the chord or the arc that subtends them. Can you see? So that basically means that angle A is equal to angle B. Now let's go and look at the proof. We are given circle O with O the center of the circle. A, B, C and D is on the circumference, and angle A and angle B are subtended by DC, which is this chord or arc. We want to prove that angle A is equal to angle B. So we want to show that this angle is indeed equal to this angle. Now we are going to start with a construction. We are going to connect OD and OC to form angle DOC at the center of the circle. So here we go. We draw in the line from O to D, there we go, and we draw in the line from O to C to form this angle at the center. Okay, now as you can see, this angle at the center is now subtended by this chord DC or arc DC, which is the same chord that subtends both of these angles. So here is our proof. We can say that angle A is equal to half of DOC. Now let me show you. This angle will be half of this angle at the center. Why? Because the angle at the center is 2 times the angle on the circumference if both are subtended by the same arc or chord. Okay, so we can simply write angle at center is equal to 2 times the angle at the circumference. Now we can do similarly with angle B. Angle B is going to be half of angle DOC. Why is this one half of this one? Because the angle at the center is 2 times the angle on the circumference if both the angles are subtended by the same chord or arc. There we go. So we write angle at center is equal to 2 times the angle at the circumference. Now I just quickly want to point this out, that we can also write that the angle at the circumference is equal to half times the angle at the center. These two mean exactly the same, okay? As long as you remember that the angle at the center is 2 times the angle on the circumference. Or you can say it in a different way, that this angle is half of this angle at the center. Got it? Now we are done with our proof, because angle A is equal to angle B because both of them is half of angle DOC, which is at the center. Excellent. Now when we have an angle on the circumference and another one on the circumference which are subtended by the same chord or arc, we can use the following abbreviation. We can say angles in the same circle segment. So when you see this, we use this abbreviation. Now let's go and look at another example that comes from this theorem. Now from the theorem that we just looked at, we can also derive the following. When we have an angle on the circumference and another angle on the circumference, and both these angles are subtended by equal chords, can you see? Not the same chord but equal chords, then these two angles will be equal. Here's another example. Here's the angle A on the circumference, angle B on the circumference. Both these angles are subtended by equal chords, so they will be equal. And if it's like this, we will simply use this abbreviation, equal chords, equal angles. Got it? See you again next time. Bye.